All right, bca1709, successfully running Active Directory in our virtualized environment here. What I want to do is take the next probably 50 to 60 minutes here, got a fair number of slides to get to, and cover a pretty common topic that comes up in our environment. I actually am a senior program manager for worldwide education, and I still teach. And I've been with VMware for about 6.5 years, and I'm still amazed at how often this question comes up. And so therefore I put a deck together. I've presented this before, and I want to take an opportunity to kind of go through some of the logic in how to make this all happen, how to move from a physical AD environment into a virtualized AD environment, give you some ideas about tips, tricks, settings that you can use to help you, wean yourself off the physical dependency of physical servers and get them into a virtualized environment. I will ask that you hold your questions until the end, just so I can make sure I get time, because I've got I think there's almost 50 slides in here, so I'm going to move along. As you all know, as attendees of this event, everybody has access to the slide decks and the presentations and conclusion of VMworld. And the reason I point that out is because I actually have a fair number of links and knowledge base articles and registry settings identified in this presentation, and don't feel the need to have to frantically write it down while the slide's going by, because you'll have an opportunity to get access to this content as well. I've also published a white paper on this on the VMware site, which of course is obviously more verbose than what we're going to cover here in the next 50 minutes or so. I like the personal touch as an instructor, so probably what will happen is after I do the presentation, I'll step off to the side of the stage here and come ask me any questions you want. Having said that, I know that there's another presentation coming in after this one, so we will only have a fair amount of time, and there's a lot of people in this room. You can always find me at the VMware booth, so feel free to just come on over and you keep me company at the VMware booth while I'm standing there being a booth babe and I have to, do my shtick. So having said that, I'm sure everybody who's been in the session so far today has seen the disclaimer slide, so we've all read it. Let's go. So the objectives and goals, and what am I trying to accomplish in this presentation over the next 50 or 60 minutes? First off, you can do it. Lots of companies have. There is no mystical or magical way to do this. It's not difficult. It's not very hard. You just want to be smart about it, and you want to make sure that you catch the things that are going to become challenges for you. In addition to that, we have many of our Fortune 1000 companies out there already doing Active Directory. A number of them do hybrid methods. They have some physical, they have some virtual. And there are some that have pulled the trigger and done 100% virtualized. Of course, there's a lot of companies out there that are still sitting on physical domain controllers, and this is a question mark that comes up. So we're going to talk through that over the course of the next 50 minutes or so. So my agenda is going to start off with, why would I do this in the first place? You know the old adage, if it's not broken, don't fix it. And so one of the reasons why we want to virtualize, we'll examine in the next couple of slides and look at the logic behind making this process happen. Of course, once we've answered the question of why we want to do it, the next question are, what kind of road bumps am I going to run into as I do this process? What things should I be watching out for as I go through the virtualization migration into Active Directory domain controllers that are running in VMs? And how do I get from point A to point B? How do I get from the physical world to the virtual world for Active Directory and Active Directory domain controllers? So we'll start off with, of course, why virtualize in vSphere environment anyway? It is fully supported. Microsoft does support Virtualize Active Directory domain controllers. I find it very interesting, after starting and cutting my teeth with VMware on ESX 2.0, that we're still today hearing Microsoft won't support that. They absolutely will. It's part of the program, the SVVP program. It is supported and it is licensed. Certainly with the new release, as of course the announcement that we made late last week with vSphere 5, performance of course has been significantly improved for virtual machines. There's a number of things. I won't go through those individual vSphere 5 features because there's 100 other presentations you can see this week about what's going on with that. It can reduce our infrastructure costs, for sure, absolutely. We have the ability, of course, to take Active Directory domain controllers, putting them in virtual machines, and reduce the footprint of the physical hardware we have in our environment. It's the old song that we've been singing for a long time, server consolidation. And of course, gives us the flexibility to actually eliminate the need for dedicated physical boxes to do this. And of course, we can implement some forms of standardization in here as well. As you know, there's a number of dynamic elements associated with this as well. Easy for testing. Perhaps you want to recompile or reconfigure your forest. Maybe you want to re-architect your domain infrastructure. It makes it very easy for testing and troubleshooting. You can use things like snapshotting for very short periods of time. We'll talk about that in a minute. And cloning methodologies. Of course, you can provision servers very quickly. We know the story about a lot of this as well. So with the SVV program, if you're not familiar with it, I did stick a link in here. Again, you'll have access to this presentation afterwards, and we're done. And you can go through that and look through that. And of course, you can see on the far right-hand side, not only are a number of Microsoft servers supported, virtualized here, Exchange, SQL, SharePoint servers in there as well. But on the far right-hand side, we can see that VMware is also validated within this program for its ESX3X products and 4X products. And of course, they haven't finalized the 5X yet. But we fully expect that'll go through the program as well. Obviously, one of the things that makes it helpful from a cost perspective is hardware consolidation and the standardization of images that we have in there. We can repurpose. If we take all these domain controllers that we have in our environment and we put them into virtual machines, we can repurpose the hardware that was running that domain controller environment in there. We can take, in many shops, still today, not everybody has the luxury of unlimited checkbooks. And a lot of these smaller shops and SMBs that are out there don't have the luxury of having multiple physical servers to separate out the roles or the applications that they have in their environment. Microsoft has told us for years and years that the old mantra, one app, one OS, one box, right? And that works really great and, of course, simplifies a lot of things, but that also becomes pretty expensive. And smaller shops can't do that. Technically, you can run multiple applications on the same box, but it's not considered to be a lead practice. Remote offices, it becomes very nice if you have a virtual domain controller sitting out at a remote branch or something for authentication purposes. And of course, we can migrate the physical hardware. You got a 4-core, 16-gig physical box running AD. We repurpose that AD domain controller into a virtual machine and run a whole bunch of more virtual machines on it. We've repurposed the physical box for that type of environment. Security is also, not the least of which, vCenter has a whole bunch of security elements associated with it as well. Of course, we know that with the Windows operating system, there's the standard 3-finger salute that we all have to give it to log in and gain access to the interface or to the features of that physical operating system. But, of course, vCenter itself also has a bunch of security role-based types and implementations that we can do to enhance that. VMs are isolated environments, as we know. That means, simply put, that if one goes awry, it doesn't take down the rest of them. We have better mechanisms of control and change management that we have in there. And, of course, attack surfaces can be eliminated using ASLR. From a testing and dev type of environment here, we can take servers if we need to re-architect our domain or maybe restructure the way the forest looks, or we want to do something along those lines. We can always take images of that physical box, put it into a storage location for somewhere located. Maybe perhaps even if it's a virtual machine, we can take a sample of that thing, put it in a test environment, test things like Active Directory or Exchange or whatever configuration that you're working on. And we've got an exact copy of the production environment in an isolated world, and you can do reconfigurations and tests more quickly, faster in that environment. Of course, you find what you like, you can move it back into a production environment, and off you go. So obviously, these are things like you may have developers developing applications that need to modify schemas. This is a great way to take that existing environment offline and do that type of scenario for them to be able to test their coding infrastructure. Okay, so let's move on here a little bit to what kinds of road bumps do I think I might run into as I go through this migration process, as I move to the other environment in here. These are probably the big kick items that we run into pretty commonly, and I've kind of listed the first one as the big one, and that's the time synchronization issue. That is probably one of the hairiest things that you want to make sure that you get right, whatever method you use, and we'll share with you the various methods that we can have in this type of environment. We want to be careful about performance-related issues. Replication can become a problem as well if you're not careful with how you construct that environment, making these virtual machines highly available in your environment. And of course, how do I recover from a catastrophic event? So let's start with the big one here, one of the biggest ones in here, and that's a time synchronization issue. So obviously, this is just a quick 30-second Windows lesson in how time management works. This diagram is simply showing you the relationship of domain controllers and servers within an active or multi-domain Active Directory forest. Of course, what's the master timekeeper in any domain? The PDC Emulator is the master timekeeper. Of course, for the forest, it's the PDC Emulator that's living inside of the forest root domain. So everybody checks in, and clients synchronize, any client OSs, synchronize with any domain controller that exists in that Active Directory domain environment, and DCs, domain controllers themselves, can synchronize with any PDC Emulator in its own domain or any other parent domain, or any DC in a parent domain in here. So it kind of feeds everything up to the top of the food chain here. And of course, you can see at the very top here, we're showing a external time synchronization to some external time source out there. And there's a number of choices, and I'm sure everybody in here probably has some form of time synchronization server in their environment or some source that they're using outside their environment in there. So why is it so important? What's the big rub about the time synchronization? Well, of course, AD is based on Kerberos, and Kerberos, of course, is the authentication protocol that exists in the Active Directory environment, and that implementation has a 5-minute tolerance window. Now, that's not news to probably everybody in this room here. Of course, it's modifiable. You can make that value larger if you want to make that value larger. In fact, we're showing you the setting right here where if I needed to increase it, I could do that. But timestamps are critically important in Active Directory for things like anybody who makes a change on their password, or we lock an account, or we disable an account. Anything along those lines. We terminated a user, or that user is not with the organization anymore. So it becomes fairly critical to make sure that we do that. The engine in AD that does all this, of course, is FRS. It's the one that moves those changes around to the other domain controllers, and of course, the last change is based in part on this timestamp. So that's why the time synchronization is so very important in Active Directory. Other services like Exchange Server and SQL Server are also critically dependent on time synchronization as well. So what happens? What's the virtualization issue associated with the time synchronization? Well, in the world of ESX Server, with VMs running on a host, as you probably are all aware, that if a virtual machine doesn't need CPU cycles, then guess what a virtual machine isn't granted? CPU cycles, right? And I think probably everybody in this room, and I say this all the time, with your A+ Hardware 101 knowledge, knows that on a physical entity, when an operating system exists on a physical box, during the post-up process of that machine, something called an interrupt timer is set. Now, the interrupt timer is based on the clock cycles of that host box, of that physical box. So things are generally okay and pretty good as long as that OS is running locally on that physical server. The challenge becomes that when you run an operating system inside of a virtual machine who only get CPU cycles when they demand them and not granted CPU cycles when they don't need them, then those timer ticks aren't getting processed. And if those timer ticks aren't getting processed on a regular basis, they begin to queue up. And of course, what happens when you queue up timer ticks and you don't process it? Well, time starts to drift. And drifting time in an AD domain controller, or any application for that matter that's time sensitive, can be critically problematic to that virtual machine. And in a very short period of time, you could realize pretty significant drift if you have other virtual machines running on those hosts demanding cycles from that host to the expense, or at the expense, of the virtual machine like a domain controller looking to process its timer ticks on a regular basis. And so idle cycles in a virtual machines that not getting CPU cycles, can be very, very detrimental to AD, Exchange, SQL Server, any of those types of applications that are critically time dependent. So we actually put this through a test. We ran a little battery on the test on this, in that we put a bunch of virtual machines on a host, not the least of which included a domain controller. And we ran some applications inside of the non-DCs that artificially hammered the CPUs from the host machine, from the ESX server itself. And that became at the expense of the ESX server. And do you know that in an 18-hour timestamp, 18 hours, that domain controller drifted by 1,700 seconds, which is more than 28 minutes. And that's in 18 hours alone. And what's interesting about that problem is it's a moot point after 5. The fact that it went 28 is irrelevant, because to the domain controller, after 5 minutes, it became a moot issue. So therein lies probably the biggest challenge that you face. And again, this is not only applicable to Active Directory, this can be applicable to any application that's very time sensitive in your environment. Okay, so how do you prevent this from happening? What are my options to do this? Well, you've got a few different options, a couple of options that you can do. One of which is we've already identified who's the timekeeper? The PDC emulator, right? So you can do some clever little things in here. And again, you don't need to be writing this all down, because you'll have these on the slides that we'll make available afterwards. You can create little WMI filtering to identify who that PDC emulator is in your Active Directory forest, because you never know. You may have AD admins who from time to time shuffle the roles around. Admins are awful, so AD admins are notorious for perhaps splitting the roles out to different servers. By default, they all live on that first domain controller, but they don't have to. They can get moved to other servers that's in there. This type of element here, this screenshot here that we're looking at, will give us an opportunity to chase where it is, or always keep track of it. So there's fundamentally a couple of really big options that you can use to manage the Windows time. First of which is to use the time services W32 time of Microsoft's operating system. That's certainly a valid way to do it. And in fact, you may choose to do that methodology, and that may be in place already. So what we're looking at here is a couple of settings. So we're making a modification change into, as you can see the string here, I don't want to read it, you can see it, it's up here on the screen, to the W232 time parameters, in which we're going to change away its default value of NT5DS to an external time source, or point it to an external time source, by using the NTP parameter. And by doing that on the PDC emulator, you can then identify some external server, maybe another server in your shop that you use as a centralized time source, that's up to you, but you point it to some trusted Stratum server that you've got out there in your environment. And of course, at that point, you can see the syntax of the command up here. You can put multiple DNS names in there. It doesn't have to be a single DNS server. It could be multiples. Could be IP addresses. You don't have to use fully qualified names. You could go by IP as well. And then what we do is we make a couple of changes to announce flags. We change that from 10 to 5 so that we prioritize the server as an NTP server. And you can also change the interval as to how frequently you want that time synchronization to take place. Last but not least, we resync, discover, and we stop and start this time service again, and then we resync it in that configuration. Perfectly acceptable solution. using the standard Windows 32 time to do that. If we point it to an external time source, off we go. Option B would be to use VMware tools. So option B looks a little different in the sense that we change that value to no sync. And when we change that value to no sync, we then turn around and we set up the ESX server or ESXi server to become, the NTP server services in that box to an external time source. Again, this could be another server within your own shop. We have a knowledge base article on how to do this. The nice thing is with the last couple versions of the software, we made a GUI interface to do that. And then we use VMware tools for its time synchronization. Now, if you notice that checkbox that you see here in VMware tools, time synchronization, you all may know this, that is not selected by default. It's not selected by default for a very simple reason. VMware has no idea what method you're using within that virtual machine in that guest OS. We don't know what's going on. I mean, ask yourself this question. Short of some additional add-on products, what does the ESX server know about what's running inside that virtual? What does the ESX server know about what's running inside that virtual machine? Not a clue. The only thing we know is that we have an operating system running inside of a virtual machine. It's powered on, and every once in a while it asks for cycles, right? So that's one of the things that's interesting. I mean, you could have 100 virtual machines without an operating system installed, all powered on, and the host thinks there's 100 virtual machines running. So we have to check that box. We make sure we check that box, so we do that. Now, by checking that box, that forces the guest OS to check in with the host once a minute. If I force that guest to check in with the host once a minute, I've also forced that guest to process some CPU cycles. And I've forced the guest to process some CPU cycles. It's also going to process the timer ticks that are inside that guest. So it won't drift. Okay. Now, what's interesting about time synchronization, if you didn't know that, is VMware Tools has always been designed to catch up, not slow down, if the guest gets ahead. It's always under the, VMware Tools is always under the assumption that the guest is going to be behind the ball, and I need to process it. And what it does not do is it doesn't jump the time inside of the guest. Instead, what it does, is the time synchronization does, is it actually makes it process all of the timer ticks that are queued. Because they have to be processed in sequence. I can't just jump the time ahead. Because if we jump the time ahead, time-sensitive applications may flip out if we do that. So we just say, well, there's 15 queued timer ticks sitting there, just run them all now. And it runs them all so the time gets caught up. And that's what we're doing with this process. So that's another method. And if your guest ever gets ahead in time, VMware Tools is not going to slow it down. It's not going to slow it down. You'll have to set the time itself or resync that guest. Whatever one you choose of the two, pick one or the other. Do not use both. Because if you attempt to use both, you will cause that guest to flip-flop in time. And flip-flopping in time, especially for a domain controller, will mess up the timestamps inside of that operating system, inside that domain controller. So you don't want to do that. How you choose which method to use is entirely up to your organization. I do want to say for the record that VMware, even in our documentation, it's on our site, all of which the links are pointing to at the end of this presentation, supports either method that you use. Of course, in a perfect world, we would love you to use VMware Tools because that's our mechanism of monitoring what's going on inside that virtual guest. That's one of the reasons why that's there, right? Because you know that VMware Tools is a way in which we can actually keep track of what's happening inside of that guest. Which decision you use is really up to you. You know, I say this all the time. I'm sure everybody in the room here knows the 7 layers of the OSI model. This last one is layer 8, the political layer. And that's the layer that you guys have to figure out in your organization, what are we going to do? But pick one or the other. That's the bottom line answer with that. So from a performance house, from the performance side of the house, as we look at the implementation of AD. So virtualized AD domain controllers typically can run at about 85 to 90% of the native physical box's capacity or capabilities, right? So everybody panics on that and says, at the end of the day, no matter how you slice it, if you put ESXi on a physical server, the guests that are running inside of that ESX host will never, ever, ever see 100% of the capacity of that box. Because you've got the overhead of ESX hypervisor running on that machine. So there's no way you're ever going to get 100%. Best you can hope for is you'll probably, for domain controllers in the traditional world, is, to be conservative, 85 to 90%. Most AD domain controllers in an environment never use more than about 10% anyway, so that's kind of irrelevant. You probably are all aware of the fact that AD is not very CPU intensive. AD is not a CPU intensive thing, it's a memory thing. AD is more about memory and having memory in there. We'll talk about that also in this presentation in here as well. And you're not going to get a domain controller to run fast. The old joke that I always use is, obviously, if you think about it, if I'm running Active Directory on a 486 DX33, and then I put it on top of a 6-core multi-processor blade, I fully expect AD to run faster, right? So virtualization doesn't make things run faster, Some of you in this room are not old enough to remember the turbo button that we used to overclock. Some of that, or memory in a tube, remember that? 8 chips in a tube was a meg, there you go. I just dated myself there. Obviously, the more domain controllers you have, the better the logon experience that you'll see, less points of failure, and so forth. There's been some changes, obviously, to the newest product in here. We're seeing significantly larger virtual machines that have the capacity to address significantly larger amounts of memory nowadays. For those that, and again, you'll see some vSphere 5 presentations, I'm sure, somewhere along this week. We're at 32 processor VMs now with a terabyte, and we can get in excess of 20 gigabytes of networking bandwidth of throughput. The IOPS are well in excess of 500,000 IOPS per second. So these are all elements that are, of course, obviously beneficial to the performance of an AD domain controller as it relates to the ESX platform. So virtualization, obviously, in summary, isn't going to necessarily increase the performance in here. It is still very important for you to follow Microsoft's FSML planning rules. They are very, very specific. They have actually a number of documents out there about the placement of the 5 FSML roles and how we do that in global catalog servers and so forth. This concept we're talking about does not preclude you from following those procedures. You should still consider those procedures as well. All right, replication. This is one that tends to come up every once in a while and cause some challenges with regards to Active Directory VMs that we get into that environment. Probably the most unsung hero that I like in the AD environment is Replmon. For those of you that are probably familiar with it, the nice little GUI. So many admins aren't even aware of that tool. I was so surprised. But this, of course, will tell you what's going on, exactly what's going on. It'll map the relationship of that multi-master model that's in your environment. You should use that as you're moving virtual machines, or you're moving AD domain controllers into virtual machines. You want to make sure that you're getting replication, it's occurring, that it's happening. You're not running into any issues associated with that. This is just a very quick snapshot of the types of connectors that are in there. Hopefully you've all been in here before. This is actually from the Repadmin, the command line version of this, just to show you that we've got an error in here, that we've got a replication error. Can't find another domain controller. It's the last successful replication and so forth. Use these tools as you migrate or as you virtualize domain controllers to make sure that they are able to communicate with the physical boxes. Because as you plan forward and move from physical to virtual world, you want to make absolutely sure you don't have any hiccups in your replication process, because that'll be really critical to the transition that's in here. Another screenshot. There's other tools, NL Test out there, DCdiag. There's a number of tools. There's some that analyzer that's available in Win 2008 R2 that came out. There's a health scanner out there. Microsoft's got a number of tools. AD Sizer. Everybody familiar with AD Sizer? That's another tool that's out there. Microsoft's got a number of tools that we can use for the AD environment here. Just a quick screenshot of DCdiag. Again, it just shows me various types of tests and checks that we can make sure that we are getting proper connection and proper replication occurring, and it's truly passing the directory partitions, and we're getting things replicated and so on and so forth. All right, let's move back into the world of vSphere and talk a little bit about some of the strategies for high availability and DR issues. Again, you do not want to stop doing system state data backups. That's still very important in its configuration. I mean, I every once in a while I hear a student tell me, or I hear a client say, yeah, we take snapshots as backups. And I look at them and I'm like, how is a snapshot a backup? And they say, yeah, we snapshot it every week so that we have a backup that we can go to. Ooh, that's not a backup. Obviously, system state data backup, and all of your commercial software that's out there can generally do this. Most of the big players can do that out there. I've referenced the VMworld placement document in here as well. And you want to make sure that you follow Microsoft's rules about how to do the backups and the restore, the authoritative and non-authoritative restores that we do there as well. The fourth bullet point is probably the big one in here as well. Restoring an AD domain controller from an old copy. So when I say backup Active Directory, I'm talking about the system state data backup, not making a backup copy of the virtual machine, right? In a lot of cases, in the smaller shops, you'll hear people say, a poor man's backup, I just power off the virtual machine and do a copy of it, make a duplicate copy of the VMDK files. Hey, that's a legitimate backup. I mean, if you made a legitimate backup copy of the virtual machine, it's a little tedious, but it works. For AD, not so good. I'll show you why that in the next slide or two. Snapshots. You shouldn't use snapshots often, and certainly not for a long time, because we have other issues which I'll point out here that snapshots can cause. In fact, it's probably important to tell you that Microsoft has specifically documented they will not support an Active Directory domain controller in a virtualized environment if it is snapshot, if it's had a snapshot on it. So they will flat out tell you that's an unsupported condition. So you don't want to get into the habit of doing that as well. And again, don't pause or suspend a domain controller for a very long extended period of time. And here's kind of the why behind the disaster recovery. And a real quick refresh on the AD environment here. So Active Directory, the beautiful, again, some of you in this room here are probably not even old enough to remember that highly scalable solution called NT4, where we had a single PDC and as many backup domain controllers as you want. Of course, in that environment, PDCs were the only version, the only Active Directory copy that was read and write. Backup domain controllers were read-only copies of the database. That, of course, led to single points of failure. So when AD came out, that was really slick because now every single domain controller had a full read-write copy of the database. And how they kept each other in check was they updated something called an update sequence number. Anytime something changed, a sequence number was incremented on that object, and then domain controllers would look, using FRS, would look in each other's sysvol folders and say, hey, do I have the current version of that? Because he's got some new things sitting there. And they would check each other and see what version of the update sequence number they had. So on the left-hand side of this pane, we're looking at a method of restore on a failed domain controller by pulling out the backup copy and turning it on. So here you are working pretty slick here. Everything looks good. You've got a domain controller on the left-hand side. You've got a second domain controller that sees the same update sequence number as the first. And there's that thing called the invocation ID, which, in a nutshell, is basically the database version, revision number. And they both see the same thing. Okay, so now domain controller 1 on the left fails. And I pull out my backup copy that I created 8 months ago and I power it on. Okay, now the second domain controller sees some very different things. It's looking at the first one going, okay, so you have the same database ID that I've got. Cool. But your records, your update sequence numbers, because I'm taking a copy from 8 months ago, has some very old update sequence numbers, so I'm not interested in getting anything from you until you catch up with me. Which of course means they're always going to be out of sync. And that's where pulling out a backup copy of an Active Directory domain controller, or one that's been sitting in a snapshot state or suspended or resumed state for a long period of time, can become problematic. On the right-hand side, if you do the proper system state restore, your non-authoritative but authoritative restores, what you end up doing is you end up resetting the database ID version. And now the second domain controller looks at that and goes, oh, you got a new database ID. Okay, well, I'll take those, and it'll take those records from it because there's something different about that database. And so that's why it's very important to make sure that we don't go with the concept of pulling out a backup copy of a virtual machine and trying to power it on, put it in there, because you'll have domain controllers, and you'll start seeing replication issues with this as well. Part and parcel to that is, of course, the automatic restarting of virtual machines. Obviously, as we all know here, this is probably not news to everybody. A couple things: your isolation response probably should be powered leave powered on. And you should probably set those domain controllers as maybe a high priority instead of, a low priority, because obviously if there's a catastrophic failure and we have to restart virtual machines, we want to prioritize our virtual machine start process. Remember that vSphere will only, or HA will only restart virtual machines that were running at the time of the failure. If those VMs weren't running at the time of the failure, they're going to ignore them. And so we might want to make domain controllers. I ask this question all the time. Has anybody in the room here ever had the joy of an Exchange server powering on that couldn't talk to a domain controller? I mean, Exchange loses its mind if it can't talk to a domain controller, right? And if you have them coming up in different sequences, that could be also a problematic issue as well. Anybody using vApps in their environments yet? Yeah. Get your head around vApps. vApps are basically containers of objects. And what's cool about a vApp is you can turn on a vApp, which can be made up of multiple virtual machines, and you can actually sequence the order in which virtual machines come up. And people tell me, hey, Chris, you could do that on an ESX host as well. The problem is that setting lives on the host. What if that VM gets moved to another ESX server? That setting doesn't apply anymore. That's why vApps are really neat. And if you have to make sure that a domain controller comes up before an Exchange server, you could put them in it's a possible solution. You could put them in a vApp and make the domain controller priority one and the Exchange server the second priority. That's another way to get around these types of situations as well. I would strongly consider creating anti-affinity rules for your domain controllers. Could you imagine a scenario in which all your DCs ended up on a single host and then poof, it goes away? Be smart. Use anti-affinity rules to ensure that all of your domain controllers don't end up on the same host. And as of 4.1, we now have modified anti-affinity rules so that you can have more than two participate in an anti. It used to be, for those that go way back, you could only create an anti-affinity rule between two. What if I had three? Then you ended up creating three rules to make sure that A and B, and then B and C, and then C and A were on the same box. Now you can put multiple servers within a single anti-affinity rule, more than two in there as well. Okay, so in essence, I think in the effort of time, I've kind of beat this into the ground, talked a little bit about that process. The issues with regards to suspending or not using system state database, you got to be sensitive to things like the tombstone record, the tombstone life of system state data, those attributes in there. I've referenced the knowledge base article in which Microsoft says we do not support DCs that are snapshotted. It is documented there. It's its KB article. And of course, keeping track of some of the key elements and critical roles, follow Microsoft's best practice on that. Fault tolerance is an option, although do we really need fault tolerance? I mean, it's certainly an option, but do we need fault tolerance for DCs? How about we just have more than one DC, right? That's the short answer to that. But it could be done. It could be done. All right, how to get from here to there? how to migrate your environment, get from your physical world to your virtual world. A couple of things about the successful migration process. Number one, obviously, like any good admin, always take a backup before you start. Rule two, do something with your switches in your environment or a port group or something so that you can process the replication records faster. Put all those VMs on the same switch or give them very good connectivity into maybe their own isolated switch for a while so they can do that. We generally, as a rule, don't need multiprocessor DCs. DCs are not CPU intensive. In fact, if you aren't aware of this, the domain controller process itself is not even multi-threaded. So there's no benefit to having a multiprocessor virtual machine unless you're an absolutely huge shop that has just millions and millions of records that are in there. Then you could probably make a argument for it. Make sure your connections are working, Replmon or Repadmin. Make sure that things are good to go between the physical and the virtual machine, and then let it sit. This is a great weekend project. Let it replicate. Now, you might notice one of the things that I haven't done in here, and that's by design, and that's use converter to convert a domain controller to a virtual machine. I would urge you highly against that. Because, first of all, what do we have to do for a domain controller? To create one, you just do DC promo. Point to an existing one. Let it do its replication. Technically, there's no real, unless it's doing something else other than acting as a domain controller, there's no reason to use the conversion process from physical to virtual. Now, having said that, the other reason why I would say not to do that is because it can become very easily corrupted. I'll tell you the converter hit rate on domain controllers, positive hit rate, can run somewhere about 40 to 60%. Sometimes people never have a problem with it. Other times, that DC just will never power up. It'll never come up because the database gets corrupted in its process. So I'd urge you to steer clear of that. Part of the other tricks and techniques that we can use is we can use some DNS wait and priority record policies with SRV records to kind of redirect logon authentications away from the physical boxes into the virtual machines. And I'll show you a couple little tricks on how to do that as well. Make sure you monitor everything's working and then deprecate or demote your physical domain controller if you want to repurpose the physical box. Should I use a physical box in an AD virtualized environment? You certainly can. Some people are nervous by that because of the fact that, some folks are old school and would like to just make sure that the physical machine, there is a physical entity somewhere in the shop in the event that the ESX server host should fail. And that's perfectly acceptable, and I understand the logic behind doing that. Transitioning the VMs in here. So in the DNS server records, there's a value. I don't know how many of you ever look at DNS records carefully, but they've got a couple of neat little values. One of them is called the weight and the priority of a DNS SRV record in here. And specifically, we're talking about the DNS SRV record for DCs, for domain controllers. Okay, is what we're talking about in this configuration here. We can use this technique to redirect logon authentication requests away from specific servers, or make it less likely that that domain controller would respond or receive an authentication request, which is a way to wean everybody off the physical boxes onto the virtualized world, into the virtualized machine that's in there. So the first one we look at is DNS weight value. That's the proportional distribution among the DNS servers. What percentage is it likely that a domain controller might receive an authentication request? By default, that value is set to 100. So there is a 100% chance that that domain controller may receive a logon request. Well, everybody's set to 100%. That means all DCs are created equal. That means they're all equally likely to be able to receive a logon authentication request. If I change that value to something significantly smaller, perhaps 25, maybe 50%, then I've lowered its proportional weight or its proportional likelihood of receiving that authentication request. Because if DNS looks at all the domain controllers that could possibly receive an authentication request, and 3 of them are sitting here at 100% or 100 value, and this one's sitting at 25, DNS is going to say, well, let's go to the hundreds. And it's a way to redirect or deflect logon authentication requests from hitting that box. And you actually should be doing that even if you're physical to the PDC emulator. Because the PDC emulator is a busy little beaver in AD. I mean, not only is he there for backup, for downward compatible or legacy applications that are still looking for PDCs, it also manages changing of passwords. It also is the arbitrator if there's a conflict between records, timestamps. So it does a lot of different things in an Active Directory environment, and probably should be not receiving logon authentication requests as often. It's a timekeeper. We've already said that. DNS priority is the likelihood that a server will actually receive a request. That's actually set to 0 by default. And if you artificially pump that up to 100 or 200, you just significantly increase the likelihood that that domain controller will receive the authentication request. And of course, as we migrate to the virtualized world, what we can do with these values is change or lower the likelihood that the physical boxes will receive these requests and redirect them to the virtualized environment. So you start managing where the logon authentication requests are going in your environment. And then, of course, you can deprecate them eventually as well, once we get everything virtualized in its environment. Here's where the values are. If you've ever looked at a DNS SRV record, you double-click on it. There's the weight and priority values in there. Does not require a reboot. That's an immediate change. It's picked up right away in that configuration. Some additional virtual machine considerations that we should look at. Number one, the add, modify, searching functionalities will benefit really significantly from caching. And that's AD database caching. And I'll get to that here in just a second. I'll show you an example of that in a slide. And it doesn't matter if you're virtual, doesn't matter if you're physical. Write operations are always somewhat of a penalty hit to the box. That's just the nature of the beast because it's a database type application. You can still use Microsoft's If you're ever wondering what size is my Active Directory database, because some people are not even sure about that, Microsoft still has that tool sitting out there called AD Sizer that you can put in number of users, number of groups, and all of that, and it'll calculate the size of your AD database in there as well. Follow Microsoft's best practice separating the database, the boot disk, the transaction logs for AD domain controllers. They have very specific documentation about separating that stuff out. Typical VM sizing, my apologies, I didn't get that to 5x in time. It still says 4x in there, but it's still relevant. If you look at this, you can see that from a processor perspective, in most cases, a single processor will work. If you get into a much bigger shop, then perhaps maybe a two-way processor that's in there. From a memory standpoint, for the caching purposes, I put an example in here that says 100,000 users or 100,000 objects is probably more accurate. And that would be the combination of machine accounts, user accounts, group accounts, all that stuff. Can get up to about 2.75 gigabytes. So there's an example of 100,000 item or 100,000 object AD environment can have about a 2.75 gigabyte. Well, if I allocate to that domain controller 4 gigabytes of memory, then what will happen during the boot process of that virtual machine is AD will load that database into memory. It will cache it into memory. And if I cache it into memory, then response time is going to be much better. Like what you can see for 3 million objects, you can see I've done that as well, added in there. Use the enhanced network adapter, separate these devices. This is pretty standard logic that Microsoft tells you to do with the disks, separating the OS from directories, from the log files and so forth. Couple lead practices in this configuration. Synchronize the forest root domain to an external Stratum 1 time source that's in there. Avoid the snapshots or redos for some of you that might be, use the verbiage. Some of you are old enough in this room to remember we used to call them redo files. Actually, you can still do those. For domain controller virtual machines. one of the things that we actually talk about in class, or we have some discussion, we talk about AD, is if you separate your OS from your database on two different disks, you can set the disk that's hosting the database, because what happens if you snapshot a virtual machine and it's got two disks? What does it snapshot? Both of them, right? If you snapshot a virtual machine that's got two different VMDK files, it's going to snap both of them. How do I get around that? One way to get around that is to change the disk that's got the directory on it to a non-persistent disk, independent disk. And if you change that, then when you snapshot it for things like, I want to snapshot it before I apply this service pack so I can roll back if I have to, then it won't do the directory database disk, but it'll only do the OS disk. And if you have to roll back, you've not rolled the database back as well. Does that make sense? It's another little trick you can do, use up your sleeve there as well. Okay, so some basic lead practices in here, and I'm in the effort of time. I got to wrap this up here. To give you a hint at what our environment looks like. We are 9,000, actually more like 10,000 users now in an Active Directory environment. We have 33 AD sites, VMware's environment, 48 domain controllers. We have 47 of those virtualized. You can see we still keep one toe in the sand, and that is we got one physical box sitting out there, and that's perfectly acceptable, guys. Really, it truly is. We have one physical domain controller that's acting as our forest PDC emulator for the time management element of that. And of course, we've had uninterrupted service for over 5 years now. Everything is AD virtualized except for that one physical box. All right, so in summary, of course, do your system state data. Make sure you do your time synchronization to a Stratum 1 time source. Test your disaster recovery plans in there. Make sure you're highly available. Monitor your traffic. And, of course, make sure that you revisit it all the time. Really quickly here, there's a couple of slides, and I just want to point out that all of these links are in the presentation, so you will have access to them after the event is over here so that you can look up and use some of these elements that are in there. And, of course, there's a couple pages of those as well. So thank you very much for your time, and I'll step off the stage here if anybody's got some questions for a few minutes.